Welcome to this episode of Robert's Creative Chronicles. So today we'll be solving this question, which states that an 8-pole DC Shunt Generator with 778 wave-connected armature conductors and running at 500 RPM supplies a load of 12.5 ohm resistance at terminal voltage of 250 volts. The armature resistance is 0.24 ohm and the field resistance is 250 ohm. Find the armature current, the induced EMF, and the flux per pole. So first we are going to draw this circuit. It's a DC shunt generator. So this is the shunt field, which is RSH, and is given here as what? The field resistance 250 ohm. Then this is what? This is the armature, and the armature resistance inside, and this is the EMF, the generated EMF, EG, or the induced EMF. So here is the load resistor RL, which is equals to supplies a load of 12.5 ohm. Supplies a load of 12.5 ohm. So this is 12.5 ohm. And the voltage here, the terminal voltage, V is what? The terminal voltage of 250 volts. This is 250 volts. And the armature resistance RA is what? The armature resistance is 0.24 ohm. This armature resistance is 0.24 ohm. Then now, the most important part is the direction of current flow. Now this direction of current flow is usually confused by most people because they don't know the direction of current flow for motors, for DC motors, and they don't know that of DC generators. The current flows from the armature here is IA and splits at this point to produce the shunt current and the load current that flows here. If it were a DC shunt motor, the current would be reversed. It will start from this point, from the load, and when it comes to this point, it will split and enter this shunt and this armature. But whereas a generator, all DC generators, the current flows from the armature to this point, then it splits. Whereas in all DC motors, whether series, shunt, long shunt, short shunt, the current flows from this load to the armature and to the shunt resistor. And for generator, it flows from the armature to the shunt and to the load. So that's all about this. So if you are able to draw this circuit, you have solved the problem halfway. Because this circuit is what will determine whether you will be able to solve the question or not. Because if you make an incorrect current flow here, you won't be able to get the correct answer. So now we have the load resistor and we have the voltage across it. That means we can find the load current IL. IL is given by voltage over RL. The voltage is what? Is 250 over 12.5. This is 20 ampere. So this load current is 20 ampere. Then we can also find the shunt current. It's also V over the shunt resistor. It's also V over the resistance of the shunt resistor, which is 250. So it's 250 over 250. This is 1 ampere. Now if you apply KCL at this point, we can we know that IA is equals to ISH plus IL, because when IA arrives at this point to divide into 2, so IA is equals to ISH plus IL. So this is equal to what? ISH is 1 plus IL is 20, so this is what? 21 ampere. So now, we have found the armature current, which is what is required here. Find the armature current. This is the first solution that is required here. Now what remains is to find the induced EMF and the flux per pole. Now the formula for induced EMF or the generated EMF for a generator is given by V plus IARA. If it were a motor, it will be called the back EMF, EB, which is equal to V minus IARA. But a generator is positive. So this becomes what? This is 250. Voltage is 250 plus IA is 21. What is RA? RA is 0.24. So this is 250 plus 21 times 0.24. This is 255.04. volts. So the induced EMF is 255.04 volts. So the last one is the flux per pole. The formula that we're going to use to calculate the flux per pole is this PNZ phi over 60A. So this A is equal to 2 for wave winding. So A is equal to 2 for wave winding, and if it were a lap winding, A is equal to P for a lap winding. But for a wave winding, A is equal to 2. So please take note of that. Let me write it here. So A is equal to 2 for wave winding and A is equal to P for lap winding. And this is a wave winding. So the flux is given by this phi. So we can make phi the subject of the formula. Phi is what? 60A EG over PNZ. 60 times 2 times 255.04 over P is what? P is the number of poles, which is 8. M is what? Is the speed, which is 500 RPM. And Z is the number of conductors, which is 778. $60 times 2 times 255.04 divided by 8 times 500 times 778. This is 9.834 times 10 raised to the power of 3. This is 9.834 times 10 raised to the power of minus 3, not 3. So it's times 10 raised to the power of minus 3 Weber. This is the unit of flux. We can also express this as 9.834 milliweber, because this 10 raised to the power of minus 3 is milli. So this is the flux. So I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email written in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share and subscribe to my channel and hit the notification bell to get notified. as soon as I drop a new video. Thanks.